All right, today we're going to dig deep, and I mean literally, into the science of something you use every single day, but you've probably never even seen. We're talking about that critical, hidden layer right under our feet known as stone soling.
So, let me just start with a question for you. When you look at a huge skyscraper or a massive highway, what do you think is the most important part? Is it the shiny steel beams, the smooth pavement, the brilliant design?
Well, the answer is, it's the part you almost never get to see. Because the strength, the durability, the entire life of any structure, from your own house to a giant bridge, it all depends on its foundation.
And that brings us to the real unsung hero of construction, stone soiling. Think of it as the first, most fundamental layer. Its whole job is to make sure everything we build on top of it, well, stays put. So let's break down exactly what it is.
Okay, so stone soling is basically an engineered layer of really carefully selected, tightly packed stones. And look, it's not just a random pile of rocks, not at all. It's a precisely built base that's designed to spread out weight, create stability, and stop the ground from shifting around. This is where a strong building truly begins.
Now, you can't just go and use any old rocks you find lying around. It's kind of like bacon, you know? The quality of what you make at the end depends completely on the ingredients you start with. And for stone soling, the specs are incredibly strict.
The really cool thing here is the shape. The stones have to be angular. So why is that? It's because angular stones lock together kind of like 3D puzzle pieces. This creates a way stronger, much more stable base than if you used smooth, rounded river stones, which would just slip and slide past each other.
And here is our first big number. The stone cannot absorb more than 5% of its weight in water. This is an absolute deal breaker, because water is the ultimate enemy of a stable foundation. If water seeps into the stone and then freezes, it expands and creates cracks. And that, right there, is the birth of the potholes you're trying to dodge every morning.
Next up, we've got specific gravity. This is really just a fancy way of measuring density. A minimum of 2.50 makes sure these stones are heavy, they're substantial. You need that heft to create a solid, unmoving base that isn't going to sag or shift under the weight of, say, constant traffic. It prevents those weird dips and waves you see in old roads.
Size is a big deal too. The breadth or the width of any single stone can't be more than 150 millimeters. That's about 6 inches. This rule makes sure all the stones are a manageable, fairly uniform size, so workers can pack them together as tightly as humanly possible, leaving almost no gaps.
And this just goes to show you how much of an engineering process this really is. It is not random. There are precise geometric rules for every single stone that goes into that foundation. It's all about creating a consistent and predictable layer of support.
So once you've got the perfect stones, how do you actually put them all together? Well, this part isn't about dumping them from a truck and spreading them around. No, it's a super meticulous assembly process, almost like building a giant, heavy-duty 3D jigsaw puzzle.
The whole process is incredibly methodical. First, you get the ground ready. Then, each stone is literally placed by hand with its biggest side down for maximum stability. Then, you get to the most important part, filling every single tiny gap with smaller stone chips. And finally, the whole thing gets hammered, leveled, watered, and compacted into one solid, interlocked mass.
This quote is right from the engineering standard, and it's basically the golden rule. You can't just shovel a bunch of loose chips over the top and hope they fall into the right places. It means every single empty space has to be intentionally and carefully filled by hand. It takes a ton of work, but it's absolutely essential to get that solid foundation.
But hey, the work isn't done just because the last stone is hammered down. This is an engineering discipline, right? So everything has to be verified. How do you know for sure that the materials you used are actually up to snuff? Well, you test them. So, samples from every new batch of stone have to go through tough lab tests. They confirm the specific gravity and the water absorption meet those exact numbers we were just talking about. This whole thing isn't based on trust, it's based on cold, hard, scientific proof that the foundation is built with the right stuff. Okay, so we've gone from the properties of a single rock all the way to the step-by-step process of laying the entire foundation. So why does all this painstaking work for a layer you'll never even see matter so much? Well, because it's the difference between a road that lasts for decades and one that's a mess of cracks after just one bad winter.
So, let's just boil it all down. The whole purpose here is stability. The key material is a very specific, hard, angular stone. The process is manual, it's precise, it's a whole system designed for one thing and one thing only, to create a permanent, solid base that we can build our world on top of.
So what this all really means is that the next time you're walking on a sidewalk or you're driving down the road, just remember the incredible engineering that's hidden just a few inches beneath you. A hand-built puzzle of perfectly chosen stones, all locked together to keep you safe. Now that you know what's under there, you think you'll ever look at a simple road the same way again?